A customer changes her address. So you update it in the sales spreadsheet, but not the shipping one, or the billing one, or the 3 others where it also lives. Now the same person has 5 different addresses, and every report disagrees. That mess has a solution, a database, where every fact is stored once and stored right. In this video, how data is really organized underneath every app you use, and the structure the ISC exam expects you to read. Welcome back. We just built a system through the SDLC, and the moment it goes live, it starts doing one thing constantly, creating data. So where does all that data actually live, and how is it kept trustworthy? That's the database. I'm Professor Lamptey. Here's the plan. What a database is, the relational model of tables, the keys that link them, the rules that keep data clean, integrity and normalization, and how a warehouse turns data into insight, all followed through our app's customer and order data. Let's define it. Write this down. A database is an organized central collection of related data managed by software called a database management system, or DBMS. Here's the contrast that makes it click. The old way was flat files, separate spreadsheets, each with its own copy of the data. That breeds redundancy and contradiction, exactly like our 5 addresses. The database approach stores each fact once, in one shared place, so everyone works from the same trusted copy. Less redundancy, better integrity, easier sharing. The most common design is the relational database, and its idea is beautifully simple. Store data in tables, like spreadsheets, that can relate to each other. Take our app's customers table. Every row is one record, one customer, like Jane Miller. Every column is one field, a single attribute, like name, email, or address. Rows are records, columns are fields. That's the whole vocabulary of a table. Now the magic is how one table connects to another. This is the heart of it and the exam's core. A primary key is the field that uniquely identifies each row. In our customers table, that's the customer ID. Jane is C-1001, and no one else can be C-1001. It must be unique, and it can't be blank. Now our app also has an orders table. How do we know which customer placed an order? We put the customer ID into the orders table too, and there it's called a foreign key, a field that points back to the primary key in another table. Primary key identifies, foreign key links. That one idea is how relational databases connect everything. Those links come with a rule, referential integrity. It says a foreign key must match an existing primary key. In plain terms, you cannot have an order for customer C-9999 if no such customer exists. No orphan records, no pointing at nothing. It's what keeps the relationships honest. And describing all of this is the data dictionary, data about the data. It defines every table and field. This field is customer ID. It's a 5-character text. It's the primary key. Auditors love the data dictionary because it documents exactly how the database is built. Now back to our opening nightmare, the 5 addresses. The cure is normalization. Normalization is the process of organizing tables to reduce and eliminate redundant data, so each fact is stored in exactly one place. Instead of copying Jane's address into every order, we store it once in the customers table, and the orders simply point to her with the foreign key. Change it once, and it's correct everywhere. Normalization is how a database helps prevent the mess from our hook. One fact, one place, one truth. We've split the data into clean tables, so how do we pull it back together to answer a question? With a query, usually written in SQL, the standard language of databases. A query can ask, show me every order Jane placed, and the database joins the orders table to the customers table on that shared key to give one clean answer. So normalization splits data apart to keep it clean, and queries join it back together on demand. You don't store the report, you store the facts once, and ask for the report whenever you need it. One more layer the exam wants. The database running our live app is built for transactions, fast, constant reads and writes as orders come in. That's called OLTP, Online Transaction Processing. But when leadership wants to analyze years of sales trends, you don't run that on the live system. You copy data into a data warehouse, a large integrated store of historical data built for analysis. That kind of analytical work is OLAP. And when you want to keep raw data of every kind, structured tables and unstructured files alike, before it's even organized, that's a data lake. Operational database for running the business, warehouse and lake for understanding it. For the exam, lock in 4 things. 1. The relational structure, tables made of rows, which are records, and columns, which are fields. 2. The big one. A primary key uniquely identifies a row, and a foreign key links to a primary key in another table. 3. Referential integrity means a foreign key must match an existing primary key, and normalization removes redundancy so each fact lives once. 4. Know a data dictionary is the metadata, and that a data warehouse holds integrated historical data for analysis, unlike the live transaction database. Get those, and you can look at any database and read exactly how its data and its integrity hold together. 60-second recap. A database stores each fact once, in tables of rows and columns. Primary keys identify records. Foreign keys link tables. Referential integrity keeps those links valid. And normalization kills redundancy, so there's one truth. Queries and SQL pull it back together, and a data warehouse turns that data into insight. If that made databases click, subscribe. Next, now that we know where the data lives, we protect it from disaster. Availability, backups, and disaster recovery. I'll see you there.